think, is we might just disagree. So we might have all the same information about tax policy. We might know all the facts about fetuses and what's going on in their cells. And we might just disagree about whether or not abortion is permissible or whether or not this is the most effective tax policy, even if we have the same evidence. Okay, so the standard view among social psychologists who look at this sort of thing is that kind of belief polarization. The last kind is irrational. So what do they mean by that? So belief polarization, the way that social psychologists talk about it, is increased disagreement after seeing the same evidence. So if you have two people and they see the same thing and then their beliefs get further apart, that's belief polarization. So why is that supposedly irrational? Well, the really natural thing to think is this: uniqueness. So philosophers have talked a lot about this thesis. Uniqueness says, given some set of evidence, there's only one right thing to believe in light of that evidence. So it doesn't necessarily have to be a belief. Sometimes evidence, you should just suspend belief about the question given some evidence. But it can't be the case that it's rational to believe that grass is green in light of the evidence, but also rational to believe that grass is purple in light of the evidence. That's not okay. So if you buy that, then that belief polarization is irrational should seem right to you. If we share our evidence, then we should be getting closer together than what we believe. So if we're doing this irrational thing, what causes it? Well, social psychologists have had a lot to say about this. So there's a bunch of different views in the literature. Probably the most well-known one is this view from Lord et al. So Lord et al. Think that there's two bad things going on. There's biased evaluation and biased assimilation of evidence. So what I take the evidence to be supporting, I evaluate the evidence based on what I already believe, so I take it to be more likely to support my view, whatever that is. And then whether or not I take on board that evidence, actually let it affect my belief, is also a function of what I believe. So Lord et al. Actually think that biased evaluation is fine, and they give a defense of that, and they think that biased assimilation is bad. But either way, they think there's something irrational there. There's lots of other theories of what could create belief polarization. So maybe it's motivated reasoning. I just really want to be someone who's pro-choice. Or maybe it's I want to identify with a social group. I really like Democrats. They have the best beard. Or maybe it's just that I don't want to not be sure about something. So these are all views that are argued for in the social psychology literature. A common theme here, as I said, though, is that they all treat belief polarization as irrational. So Ross and Anderson sum this up very clearly. They say belief polarization is in contrast to any normative strategy imaginable for incorporating new evidence. So if belief polarization is irrational, that would be, in a sense, good for society, right? Because then we could try to correct that irrationality and get rid of the polarization that we see in politics. I guess what I'm going to argue for here is some bad things. So belief polarization is not necessarily irrational, is what I'm going to try to convince you of. I made this myself. Okay, so here's the plan. So I'm going to give you a methodology. Marcelo basically summed up the methodology already. It's do science, but I'll say a little bit more. Then I'm going to do the science. So I'm going to give you a way of thinking about group deliberation or society deliberation about questions. Then I'm going to tell you about a model. And then I'm going to give you some results from running the model. It's a simulation. And then I'm going to argue what's going on in the model, that it's agents acting rationally. So just seeing the model is not going to entail that what they're doing is rational. So I'm going to have to make that argument separately. And then at the end, I'm going to draw some more implications of the model I mentioned. Before I go on, I want to mention that the work I'm discussing here is done on the model of science, which philosophers, the exception of at least one philosopher in the room, actually, but most philosophers do philosophy on the model of science. But these folks and I are at the left. Here it goes. All right. So we use other kinds of models. We teach undergraduates comparative traits. One kind of model that is common to see is agent-based models. Agent-based models. So agent-based models have these features. If you're going on agent-based models, there's usually similar and they're similar interact they could think of this as maybe their belief about how effective some particular medicine is, or something like that. And then the agents all have neighbors that they talk to. It might be everybody if you've got a really simple model, or it might be just their neighbors on the social network. And then on each round of the model, they do something like averaging to update. So they talk to all their neighbors. They say, oh, I'm a 0.5 person, and Marcelo's a 0.9 person. So next I'm going to go to the average of 0.5 and 0.9. And so there's lots of extensions of these sorts of models, but there's a lot of discussion of models in the belief dynamics literature that work something like this. So it's been known for a long time, and if you try to program this, we have undergraduate students at Penn, but if you try to do this, you'll probably get a model that converges. So Ableton puts it this way: ultimate agreement is a ubiquitous outcome of a very broad class of mathematical models. What must one assume in order to generate a binomial model? Any kind of model like this, you can see everyone's going to collapse, because if you're doing something like averaging, everybody's just going to get closer together. There are ways of doing thin agent-based models with averaging like this, where you can get polarization. So Ableton was actually wrong. So Egglesman and Kraus have a model like this from 2002, instead of version 4, where they do this sort of averaging and get polarized society. And the way they do it is, if you only talk to people with beliefs near yours, then you can get groups that form. I'm happy to talk more about that later. It is possible, but I'm going to give up on the averaging model altogether. Alright, so here's a new model of agent group deliberation that doesn't involve any kind of averaging. Okay, so here's going to be the starting part. To model group deliberation, we're going to start with this idea that rationally what a group should believe, what a person should believe, is what's supported by their evidence, or what's supported by their reasons. So an agent's going to have a bunch of reasons, and what they should believe is what's supported by their reasons. And then deliberation in this model is going to be the exchanging of reasons. So I believe that abortion should be permissible. Why do I think that? Well, here's my reason. In these particular models, we're going to assume that everyone hears everyone, and there's not going to be any analog of like shouting or threats or anything like that. One more thing about the model. The last thing is that in this model, sometimes agents are going to be able to get reasons from the world. Because we don't always figure out what we believe from each other, right? We learn a lot from each other, but sometimes you go out into the world, you do an experiment, and you figure out somebody didn't tell you. Okay, so you can also get reasons from the world. So 12 Angry Men, he goes, the guy, the juror 8 goes to the pawn shop, finds the knife that's supposedly rare. Okay, that's a reason to think that the knife wasn't as rare as he previously thought. That's a reason. Alright, how are we going to model reasons? A reason on this model is going to be a very simple thing. It's just going to be a thing that it supports, thinking that the 18-year-old is guilty of and then it's going to be a strength at which it supports the So a reason is just that. There's nothing else to a reason in the model. It's just guilty or not guilty, and then a strength. So maybe 3. So here's a picture. The reason A is just a supporting of guilty, strength 3.2. And for the models I'm going to show you, we're going to make some simplifying assumptions. So we're going to assume there's just 2 contents we're discussing, guilty, not guilty. We're going to assume there's lots of reasons. So here you can think jury trial again. So there's lots of things that might bear on whether or not this 18-year-old actually did kill his father. But few of them are very strong reasons. It's quite rare to have eyewitnesses that this guy do that. So then if we were to plot out the reasons, they might look something like this. So we'll give the reasons a positive strength if they support guilty, a negative strength if they support not guilty. Then there's going to be lots of reasons with strength 0 or near 0 that don't tell you much about guilty or not guilty. There's going to be very few reasons that tell you one way or the other. Say is that a person's belief is just a weighted sum of whatever reasons they have. Okay, so that's going to be the model of reasons. Obviously, this is incredibly simple, and you might think there's a worry here. So one worry is that stems from this idea that the reasons just have basically no structure. They just support the context. The worry is that we can't even do simple interactive things with groups. So oftentimes what happens when you have a group discussing is that you could have 2 people say different things, and those things come together to support something that neither individual part did. So maybe I know P, and Marcelo knows if P then Q. Well, then if I say P and Marcelo says if P then Q, then we can collectively conclude Q. right? But neither P nor if P then Q by themselves supports Q, right? So you might think our model of reasons is just too simplistic, right? It can't capture those reasons. And the response to that is going to be a few things. So one, we're trying to give a really simple model. It's supposed to be a thin agent-based model. Here's another move if you don't like that. You could think of the reasons as lines of argument. That doesn't really get around the objection, right? But, okay, then in our model, people can only exchange lines of argument for conclusions. They can't actually have this back and forth thing. But the last response is I'm going to come back to this, so we have a better response. But for now, just go with it. All right, the last element of the model is going to be memory. So some agents, according to epistemologists, but not according to anybody else, have perfect memory and never forget anything. But real agents are never like that, right? We all forget things. We have limits to how much we can remember. So if we're going to model this, we need to have ways that agents forget. How are agents going to forget things? So one way they could forget things is when their memory gets full, they could just drop something at random. So that's really bad computer design, but you could do it that way. Another thing you could do that's plausibly more rational is you could forget the weakest reasons. The reasons that have the lowest strength, forget those first because they don't bear as much on the conclusion. Here's another thing you could do. You could forget reasons that go against what you believe. So at any moment in time, you're going to have a collection of reasons. They'll collectively support something, guilty or not guilty. And you could look at your collection of reasons and go, okay, they collectively support guilty. So if I have to forget something, I'm going to forget something that supports not guilty, because that's a misleading reason. Okay, so those are three ways that agents could forget. So we're going to simulate this, and I'm going to show you some results from simulation. I'm going to show you two different kinds of runs. So in the first kinds of runs, they're going to go like this. So there's going to be 50 agents, and at the beginning, they're all going to get 7 reasons, just random. Each agent will get 7 random reasons from the world, possibly different ones. These numbers don't actually matter at all. We've done tons of robustness testing for all interesting numbers. Results work, but I'm going to show you numbers for these. Okay, so 50 agents, they all get 7 reasons. And then a random person just says a random one of their reasons. Everyone's going to hear that reason, take it on board, adjust their belief. And then if the agents are limited, then everyone who has more than 7 reasons is going to forget one. So if everyone starts out with 7 and then a random person says a random one, well, not everybody's going to have more than 7 now, because the person who's speaking is not going to have more than 7. And if people already had that reason, they're not going to have more than 7. But if somebody now has 8, they're going to forget the reason using whatever forgetting rule works. Okay, so that's pure deliberation. It's really simple. All that happens is we have this setup, you get your reasons, and then we do this repeating thing where a random person says a random reason, everybody adjusts their belief, and then everybody forgets if they need to. And then repeat. A random person says a random reason, everybody adjusts their beliefs, everybody forgets if they need to. The other kind of run is going to be deliberation with outside input. Deliberation with outside input is very much like deliberation, the pure deliberation cases, except that before anybody says a random thing, everybody's going to get a reason from the outside world, just some random new reason. And that's going to repeat. So what's going to happen here is everybody's going to get a new